Hello everyone, I am Behrooz Kavehie. Today we are going to learn how to perform a statistical analysis of decision tree in SPSS environment. The decision tree statistical method is renowned for classifying cases across various categories and is fundamental in the field of machine learning. In simple terms, a decision tree is a hierarchical chart that illustrates a clear path to decision making. In this presentation, I will demonstrate how to utilize IBM SPSS for conducting a decision tree analysis and interpreting the resulting output. The data in this article consists of information about the passengers of the Titanic ship during its sinking. The data file structure, of course edited and modified from its original format to our special purpose, is followed as the data in the SPSS environment is like this, the structure of data. And the structure of data is like this. As can be seen, the passenger class variable, which indicates the type of the ticket and the social status of the passengers, has three categories: first class, second class, and third class. Or lifeboat variable, indicating access to the lifeboat, has two categories: yes or no. Some dataset records are like this. We labeled the value of the variables for better understanding in results. Note, every entry represented a single person. This is person number 1, this is person number 2. Number 1, first class, female, age greater than 7, from Southampton. She has lifeboat and she is alive yet. On this page, we have frequency distribution tables of the variables under investigation. For example, in the survival table, we can see that the number of living people is 499 people, about 38%. And the number of dead people is 808 people, about 62%. Other variables are the same. From main menu, follow this path to start calculation. Analyze, classify, and then tree. You will see this dialog form. In this section, you can see the variables in the active dataset. Complete the dialog form entries as follow. Enter the response or dependent variable here. Enter the predictors or independent variables here. And choose the method of tree grew with from here. Note that there are four main ways to grow a tree: chi-square, automatic, interaction detection, and others. You will see the result by pressing the OK button. On the first page of the output, you can see a summary of the model's parameters and the specifications. For example, grooving method, dependent variable, independent variables or predictors, and so on. On the second page of the output, you can see the generated tree. All main results can be seen in this hierarchical tree diagram. In this diagram, 9 nodes have been obtained. Of course, if we change the way the tree grew, this structure will change, and even the number of nodes may vary. In following pages, I will present examples produced by other methods. In each node, we see the frequency and percentage of response variable levels like alive and dead, alive, dead, alive, dead. Frequency percentage. For example, in node 3, we see where the people have access to the lifeboat access yes, and are women, gender female, node 3. The number of living people is 318 and the number of deceased is 1. This means that a person with these conditions will survive this accident with a probability of 99.7%. Look at the diagram. Okay. On page 3 of the output, we can see the risk and classification table. From the risk table, it can be seen that our estimation error is about 2.4%. 2.4%. In percent, this means 2.4, which is an excellent result. The classification table is a two-way table like crosstab that tabulate the actual observation and estimation. Observed, estimate, or predict. For example, the model was able to estimate that 476 people actually survived, and it was only rank 23 people of the living. No. 23 of yes. It also estimates that 799 people who died were dead, with an error of 9 people in estimating the number of deaths. As a result, the final accuracy of the model is 97.6%, which is considered a great success. Here is the corrected version. Excuse me. On this page, you can compare the 4 diagrams generated by 4 different grooving methods: CHAID, excessive, CHAID, CRT or regression, QUEST. Note that we use CHI, a square automatic interaction detection, in this paper. CHI means chi square or chi2. Please take a few minutes to look carefully. Okay? Now it's time to predicting an outcome using model. Suppose we wish to determine a person's fate based on these 5 characteristics: age greater than 7 years old, class first class, gender female, access to lifeboat yes, embarked port Southampton. I think this is better that we run this part on SPSS live. Please wait. This is the data set. We are working on it. With this button or icon, you can see raw data or labeled raw data. Here is 2 missing value. Okay. Move to the end of the active dataset. Create a new row with the specific characteristics. First class, female, age greater than 7, Southampton, lifeboat, access to the lifeboat yes. These are our condition. These are. Leave the dependent variable survival empty or missing value or null. This is our person that we want now the fate, his or her fate. Now open the decision tree dialog box from the Analyze, Classify tree. Move survival to dependent. Move other variables to independent. Use your method for growing. CHAD, chi-square. Press the button Save. Tick the predicted value. terminal node number, predicted probabilities. These three ticks give us the result. Run, continue, run. Here we have the results. Minimize. Look at these 4 columns. These columns are generated now. Node ID, predicted value, predicted probability 1, predicted probability 2. This one is for alive, this one is for dead. And the person of 1310. This is the survival situation, unknown. Using node ID number 3, the conditions are like the people we want, the person we want. Using node 3, the prediction is 1. 1 means alive. 2 means dead. Then fortunately that woman survives. Probability of alive, probability of death. Thank you for your attention. Stay with us.